So we were discussing about a sphere, right here, a sphere of radius small r. What did I
Yes,
say?
sir.
What's the last sentence?
A sphere of radius small.
As shown in.
As shown in the figure, is pulled by a horizontal force F, right here?
Yes, sir.
Yes, sir.
Find the direction. Find the direction of force of friction. Find the direction of force of friction acting at the point of contact P. Find the direction of force of friction acting at the point of contact P. Please get reminded on what I told you when we were dealing with friction. And I told you I'll be using the same in rotational mechanics.
Sure.
Whatever concept was aired then. And the concept being, whenever I am to decide on friction, I am to assume there is no friction present. Correct, dear?
Yes,
Yes,
sir.
sir.
Yes, sir.
As I am to decide on direction of friction, I'll assume there is no friction acting on this sphere. Whatever it may be, there is no friction acting on it to begin with. And then what I am to do? The two equations which I have always advocated for. Which two equations they are? Please keep it in your mind. And accordingly will be your problem solving much eased. There are only two equations which you seek. Equation number one, which is to highlight translational aspect of body. By that I mean motion of center of mass. Correct, dear?
Yes,
Yes,
sir.
sir.
Yes, sir.
Which is to highlight rotational aspect of body. By that I mean writing for torque being at center of mass. Correct?
Yes,
Yes,
sir.
sir.
So let us write both the equations here. In the horizontal direction, tell me how many forces are acting on center of mass. In the horizontal direction, how many forces are acting on center of mass? Think of the center of mass. Assume that this body has condensed to a point. Is it okay, dear? This
Yes,
body
sir.
has condensed to a point. And how many forces are then to act on, or otherwise as well will act on that point? This point you got only now. You're condensing it to a point. And which is the best point to represent any body? Of course, center of mass. Correct, dear?
Yes, sir.
Yes,
So
sir.
one center of mass acts up. One center of mass acts in the upward direction normal, in the downward direction mg. Correct?
Yes,
Yeah.
sir.
The total forces shown barring friction being these, what we are then to say from here that only force in the horizontal direction being F, let us realize an equation of motion in horizontal direction. Will you approve of this equation for center of mass?
Yes, sir.
In the horizontal direction, fine, Krish?
Yes,
F
sir.
is equal to m into ACM, or to be precise, ACMX. Tell me, why did I say ACMX? Because force is in x direction. Correct, yeah?
Yes, sir.
Force is in what direction to us? In x direction. Corresponding acceleration will also be in x direction. So this ACM is nothing but ACMX, correct?
Yes, sir.
We did not be assertive on it. Why so? There is no motion along y direction. So it's a given that ACMX is equal to ACM, right?
Yes, sir.
Yes, sir.
Okay, so it suffices. F is equal to m into ACM you can write. Because ACMY and ACMZ, they are individually 0, right? Yeah. ACMY and ACMZ, they are individually 0. Correct, Krish?
Yes, sir.
Okay, so this equation is good with all of you, Adesh?
Yes, sir.
Yes,
Okay,
sir.
next what? Next, what shall I do? I shall be put at center of mass of system, correct?
Yes,
Yes,
sir.
sir.
Please, I put myself at center of mass of system and then try find torque. For me, torque equation here about this point.
The
Torque
I
equation.
omega.
Let me ask. Yes, yes, Adesh, tell me torque equation.
So I omega.
I omega is the after effect. First, tell me in terms of F. What will it be F? In terms of F, what will be torque about this point? How do I calculate torque due to a force?
So torque due to force is the perpendicular distance from the point of calculation to the line of force. So
Very good. So what is line of force over here, Adi? This is the one?
yes,
Yes,
Line
sir.
of force. Line of force means the line which houses force. Correct, yeah?
Yes, sir.
So this is the line, isn't it? Which is
Yeah.
housing
yes, sir.
force. All of you?
Yes,
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 sir.
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 Okay, so this is the line which is housing force, and what the perpendicular distance?
Sir,
Perpendicular
R.
distance you know is capital R the radius, right?
Yes,
Yes,
sir.
Yes, sir.
sir.
So F, if I multiply with capital R, certainly I'll get torque due to F about point of calculation, which happens to be the center of sphere. Correct, yeah?
Yes, sir.
Yes, sir.
Okay, now let me be an ask on direction. How do I get direction? Yes, Vedant, tell me. In order, this is the magnitude of torque, right, Vedant?
Yes, sir.
Now,
So
if
it will
I
be in the
get
clockwise
direction,
direction.
what is the methodology? How can I get direction? Which equation shall I use to get direction of torque? I have to use vector equation. What is the vector equation? Vector equation of torque.
So vector equation. So
Torque
torque
is
equal.
equal to, we have studied about torque, Vedant. Torque is equal to
Yes, sir.
what?
So torque equals to vector F multiplied by the.
No, that is fine. I got your point. You are indicative of magnitude, F multiplied with perpendicular distance. That is good with me. I'm asking for what about direction? When I seek direction, then you'll have to let me know of the vector equation. Then I cannot say force multiplied with perpendicular distance of line of action from point of calculation. This is the methodology by which I get magnitude. But over here I'm particular, and I'm particular on direction as well. So let me know from you how to get direction. What equation do we use for direction? There is a vector equation, Vedant. We cannot be losing on those. Tell me, dear. What is the vector equation for torque? Quickly, please. Adesh, what say you? Adesh, you have any say?
Sir, is
What
the
is the vector
direction
equation?
out of the board, sir? So out of the board.
First, you tell me the vector equation. What is the vector equation for torque? Torque was studied as cross product of something with something. What is this? I am not able to answer.
So
I'm really
R
very
S sine theta
sorry.
n
This is
cap.
fine. I will be able to, but I am appalled. Let me tell you, I'm appalled. And if you feel that you all are
Sir, is
making
it
light
the
of what I am asking you, then you are calling upon yourself. Mind you, if you will not perform, I'll be the first person to withdraw, come what may. And you are known to this. I have heard it many a time. So please,
yes, sir.
what are the basics you need to commit to memory? Devise your own methodology. I'm not at all impressing on my point that you write. You don't write. Give two hoots to what I'm saying. I'm okay with it. I'm okay with you giving two hoots to what I'm saying till the time I get what I am to get from all of you, which is the basic must be instilled. It must be etched in your brain. And if basics you are having problem with, then please spare me some blushes. I will not continue. I'll withdraw. I'll go with only one student who is deemed to be continued with. Am I clear to all of you?
Yes.
Yes, sir.
Yes, sir.
Please be careful about next time. Torque is equal to R cross F. Torque, the basic equation from where I coming. How can you lose on it? Torque is equal to R cross F. This is the only equation in vector for torque. And this is how it is defined. Torque is equal to R cross F. I told you that
Sir, I cannot see you.
Vectors F tail, correct dear? That means it connects the point of calculation.
Sir, I can't see you.
The screen is freezing. Yeah.
Someone was calling. Is it fine now?
Yes, sir.
Gagan was, the student was calling. Is it fine now?
Yes, sir.
Yes, sir.
So what is R over here? The tail of R. Where will it be? Again, don't lose on it. I'm repeating again for you. I've lost count on how many times, yet I am repeating. What is the point where should fall tail of R vector? You will say point of calculation, correct?
Yes,
sir.
sir.
Yes, sir.
And where will lie head of R vector? At the point of application of force, correct?
Yes, sir.
Yes, sir.
So what is R vector to you? R vector is in a way position vector. Find ya.
Yes, sir.
Yes, sir.
Yes,
A
sir.
vector which is positioning point of application of force. Can I say so?
Yes, sir.
Yes, sir.
Very good. And whenever I am to find cross product, what is the most important aspect of the finding? Any one of you?
Sir,
What
you
is
have
the
to.
important aspect of finding cross product? Yes, Krish.
Sir, you have to join both the tails of both the vectors and you have to direct them to the smaller angle.
Very good. You have to join the tails. So first let me show you the organic R. This will be organic R, correct, yeah?
Yes,
Yes,
sir.
sir.
The organic R, the actual R, correct? Why? Because this is
Yes.
my point of calculation and this is point of application of force. So this is the actual R. And if I am to find cross product, what I'll do in adherence to what did Krish say, I have to bring the tails together. And when I'm to bring the tails together, I am to be in compliance with that vector should not get changed. And vector cannot be changed. By that, what I mean that I can transport my vectors easily I can, but I need to keep a check on the direction of transportation. By that what I mean, I can transport vectors parallel to their parent position. Correct, yeah?
Yes, sir.
Yes, sir.
So let me transport this vector parallel to its parent position. This is R for me. And then as per what did Krish say, we are to curl it. As per what did Krish say, we are to curl it. Curl it through which angle? Smaller angle. Correct, yeah?
Yes, sir.
So,
Yes,
through,
sir.
through the smaller angle.
Yeah, yeah.
Yes, sir.
As per what did Krish say, I am curling my finger or rotating a right hand screw, whichever is easier to you, keeping in mind that we are to do it, actualize it through a smaller angle. Correct, yeah?
Yes,
Yes.
sir.
So
Yes,
that is
sir.
what we are doing, actualizing it through a smaller angle, and that will get us the direction of R cross F, which will be, yes, Adesh, into the board, out of the board.
So will it be? So it'll be into the
Don't
board.
ask me. Don't ask me. I'm on an answer. Don't ask me. Will
Sir.
it be? I want an answer now.
Yes, sir. It will be in the. It will be into the board or minus
Yes,
K
very
cap.
good. Very good. It will be into the board. The small r cross f will be into the board. Very good. And also we know that if I am to find magnitude, whatever you said over here, Adesh, could be gotten easily from this equation
R
as
sine
well.
theta.
How? See for yourself. What will be magnitude of small r? Magnitude of small r will be capital R, correct?
Yes, sir.
F remains the same, right here? And what angle shares
Yes.
R with F? 90 degree. So sine 90 will be what to
Yes,
get
sir.
you 1, correct?
Yeah.
R.
Yes,
Yes.
Yes, sir.
Right here, so we got the same, find here. So that
Yes,
is
sir.
what is being
Yes,
also,
sir.
as I told you to keep on muttering it, also being aired as perpendicular distance measurement with F, correct, yeah?
Yes, sir.
Yes, sir.
Yes, sir.
Now, the other representation for torque, as we are coming from, L is equal to I into omega, right, yeah? We
Yeah.
are coming from this equation.
Yes, sir.
When we differentiated it, we got torque is equal to, if I is constant, then I into alpha. There are times when I can also change. IT did ask a question in which there was an insect which was moving. So that was asked about 10 years ago. So in that case, I will also change. Over here, I am of the opinion that I is remaining the same. We will take in questions what will happen when I will change. Correct, yeah?
Yes, sir.
So now
Yes, sir.
I is constant. Okay, Krish?
Yes, sir.
So I is constant, getting a torque is equal to I into d omega by dt, which is what is to be replaced by alpha and is read to be henceforth, hitherto it is to be read as angular acceleration of body, given body. Clear, yeah?
Yes, sir.
Agreed,
sir.
sir. Yes, sir.
So tell me, can I now mark it as I not into alpha?
Yes, sir.
Yes, sir.
Can you tell me what is this I not and what exception it is from I? What that not there is to specify? Is that not an essential element or we can do away with it? What is in general meant by this not? Why did
That's the
I
initial value.
try to present it in this form? I would have said it will be I into alpha as well. And there is no question this will also be right. But I wanted you to read something of this symbol. This symbol will be invariably used. Could you please tell me how can you distinguish between a simple I and I not?
Sir, is I not the initial value or the base value like that?
Moment of inertia for a given body till the time you dephase it will remain the same, right? Yeah.
Yes, sir.
Moment of inertia depends on mass and how the mass is distributed. So till the time I'm not changing mass or the distribution, which I'm not, for any rigid body, I'm not changing the distribution, then moment of inertia will remain the same, correct? Yeah. So
Yes, sir.
initial you can say when moment of inertia is changing. I told you that I'll be taking that later. For me, now moment of inertia is not to see any change. So moment of inertia is constant. So I don't think it will relate to initial moment of inertia. Anything else? Moment of inertia we calculate about an axis, right, dear?
Yes, sir.
Yes, sir.
Yes, sir.
Inertia about an axis. Do you remember how did I get all? What was the reason to call it moment of inertia? What was there required for me to represent mi ri prime square? If you can check once, mi ri prime square, where ri prime was the distance from the axis of rotation, perpendicular distance, right, dear?
Yes, sir.
Yes, sir.
Yes, sir.
Then we said that now onwards we will be writing this quantity, which is summation of mi ri prime square, as moment of inertia about axis of rotation. Correct, yeah?
Yes, sir.
Yes, sir.
Yes.
So there can be multiple axes of rotation for a rigid body. It can rotate about infinite axis. Yes or no?
Yes, sir.
Yes, sir.
Yes, sir.
The axis taken by you passes through center of
Center.
mass of a given body. If the axis taken by you passes through center of mass of given body, correct? Yeah?
Yes, sir.
Yes, sir.
Then we in general use ICM or I naught for moment of inertia calculation about that axis. Clear?
Yes, sir.
Yes,
So
sir.
I naught will be what henceforth be read by you. I naught henceforth is to be read to be the moment of inertia calculated about an axis passing through center of mass of body under study. Am I clear?
Yes, sir.
Yes,
The one
sir.
Yes, sir.
question.
That is invariably the case. So you can take it a given. Whenever is I naught being mentioned anywhere, it is indicative of moment of inertia about an axis passing through center of mass of given body or body under consideration. Clear, dear?
Yes, sir. So
Yes.
one question.
Yeah, dear.
Has there been any question where they've given I not as the thing and they've asked to find anything like that?
I not taken. Yeah, of course, there is, and I'll be coming to that. that in order to find I, you need to have a know on I naught. If you want to find I, Krish, for anybody, then you need to know what will be I naught for that body. Only then you will be able to find or use parallel axis theorem. So I'll be coming to parallel. What is exactly parallel axis theorem to make you understand? I naught is incumbent on us. It is imperative on us to get at least the minimum no for body, and that is the no against an axis passing through its center of mass, because that is the easiest moment of inertia calculated for any body. Is it okay?
Yes, sir.
And that is what is being marked as I naught. So that's the distinction. I naught without, in more cases than one, I'll say, an exception case anyone can pick on just to show that he is from a different school of thought. But in general, I naught, wherever in good books, celebrated books, if I naught being mentioned, then you take that being moment of inertia about an axis passing through center of mass. Is it okay?
Yes, sir.
So this I naught is no exception. This also is moment of inertia about an axis passing through center of mass. Then you may ask, what's so big about moment of inertia about an axis passing through center of mass? Why I'm going hammer and tong that I should take I naught? And to answer your question, I am to counter question asking where am I put up? What will you say? Where am I put up? Where am I put up when I'm writing rotational equation? Where should I be?
At the
Where
center.
should I be?
The center.
When do I qualify writing rotational equation for body? Come on, tell me. Where should I be? What is the
Center.
statement?
Sir, at center of mass. At
At
center of
center of mass. So I am at center of mass. I am positioned at center of mass. So if I am positioned at center of mass, then body is rotating about an axis passing through center of mass, right, dear?
Yes,
Yes,
sir.
sir.
Yes, sir.
Body for me is rotating about me, isn't it? Can I say that? Body for me is under pure rotation about me. Yes or no? Think about it.
Yes,
Yes,
sir.
sir.
Please get the sense of what I'm trying to suggest over here. Please get the sense of what I'm trying to suggest over there in its form and manifestation. Everything should be clear. In letter as well as spirit. What did I say? Body is rotating about me. Do you buy this idea?
Yes, sir.
Yes,
Yes,
sir.
sir.
Body is in pure rotation about me. Do you buy this idea?
Yes, sir.
Yes, sir.
Yes, sir.
So can I say that it is a case of rigid body rotation about fixed axis?
Yes, sir.
Yes, sir.
That's what I am taking. So this is the axis to me, and the body is rotating about fixed axis. Correct, yeah?
Yes, sir.
Yes, sir.
Yes, sir.
So it's a rigid body rotation about an axis, and this is the axis which I have hinted. Mind you, I naught can be this, I naught can be this, I naught can be this, any moment of inertia read. Any moment of inertia read for an axis which happens to intersect the center of mass of given body will qualify being marked as I naught. Am I clear?
Yes, sir.
Yes, sir.
And owing to symmetry of body under discussion, owing to symmetry of body under discussion, can I go over the top? I'm asking. Can I go over the top and comment that this I naught, this I1, I2, I3, they are all to get you I naught. Agreed or not?
Yes, sir.
Yes, sir.
Why? Because the body is symmetric, right, dear? So distribution remains same, right, dear? So you
Yes,
take
sir.
this axis, this axis, this axis, this axis, you take any axis. I naught will read whatever it is reading against this axis, right?
Yes, sir.
Yes, sir.
Okay. But for me, which is to count? The one that I'm showing now. Am I clear?
Yes, sir.
So my axis is perpendicular to the green board, correct, dear?
Yes,
Yes,
sir.
sir.
Yes, sir.
And now one may ask why? Why have you taken that axis? Why is that you are hell-bent on taking this as the axis? If I naught is same from all the axes, take any axis. It's all about I naught. What will you take that? What will you tell that person? You'll tell that person, look at the left side of equality. Look at the left side of equality. Right, dear?
Yes, sir.
The person will say, fine, it is f into r. Then you will ask that person, what is r over here? What is r over here? R is what to you? R is the perpendicular distance. From which axis? Are you getting it?
Yes, sir. Yes, sir.
Are you getting it, class? R is the perpendicular distance. Okay, perpendicular distance from point of, you know that very well. But if I am to now change point to axis, about which axis shall I take rotation? Can I take it about this axis?
No.
Can I take it about this axis?
No,
No, no, sir.
Which axis shall I take? This one, correct, yeah?
Yes,
Yes, sir.
So I naught also is to be read about the same axis, correct, yeah? Yes or no?
Yes, sir.
Not, yeah.
Yes, sir.
Yes, sir.
Okay, so I'm taking time to get it instilled. Please don't lose on it. It is very easy to lose. Please retain the concept. It is of team import. 80% of your education depends on what you are able to retain after of a year or two. So please be very careful about it. F into R is equal to I naught into alpha, and that is what I have written. Now I am an ask, and that being for solid sphere, as I have told you, and I'll be proving in time to come. Please take a note of whatever I say. Please take a note. Please make a note of those. Okay. If I say that I'll be proving, I may miss on it. But if you are making a note of it, you will ask me to prove those. So please make a note of those. Moment of inertia for a solid sphere is 2 by 5 mr square, right? Yeah.
Yes, sir.
Yes, sir.
Okay. And into alpha, I multiplied with alpha, right?
Yes, sir.
Yes, sir.
So what do I get to see from here is 5f by 2m r. And r I'll take that side. 5f by 2m is equal to r into alpha, right?
Yes, sir.
Yes, sir.
So from second equation we get r into alpha is 5f by 2m. And from first we get ACM or A is equal to f by m. A is equal to f by m and r alpha is equal to 5f by 2m. Please check this, class. It is
Yes, sir.
neither theory nor problem. But if you don't know this, you will not be able to write your equations. To write equations, you require direction of friction. So this is in a way a methodology which cements your position on direction of force of friction. Am I clear?
Yes, sir.
Yes, sir.
Okay, now if I have taken a solid sphere or sphere as we call, we get to see R alpha is greater than A. Agree?
Yes, sir. Yes, sir. Yes, sir.
We get to see R alpha is greater than A. And if R alpha is greater than A, then this point will have a tendency to slip backwards. How I know? A minus R alpha. Can you recollect? A minus R alpha in which direction? I can you recollect it there? Acceleration of center of mass. If you cannot recollect, then you can write by yourself. Acceleration of center of mass with respect to Earth. What will it be? It will be acceleration of center of mass with respect to center, right? Yeah.
Yes, sir.
Center
Yes,
of
sir.
mass center plus center with respect to Earth. Correct? Yeah. Check it out. Yeah.
Yes, sir.
Yes, sir.
And center of mass with respect to center will be, as you know, what did I write? Center of mass will be acceleration of P now, of point P. We are writing P. P with respect to this will be P, right? Yeah, P. We are calculating for point P. Acceleration of point P with respect to this point. Is it okay?
Yes, sir.
Acceleration of point P with respect to Earth will be acceleration of point P with respect to center, this center, and acceleration of center with respect to Earth. Correct, yeah?
Yes, sir.
Okay. Now, if I am at C and looking at P, In which direction will be acceleration? Backwards, correct? Yeah. Check it out. Check it
Yes,
out.
sir.
Will it be backwards or not? Backwards or not? Think, see for yourself. Will it be backward? This point backwards.
Yes,
Yes, sir.
sir.
Yeah. Yes, sir.
Okay. And what will it be equal to? Alpha into r. In what direction? Minus I cap. Find here.
Yes, sir.
And then we go for the second one, which is of center with respect to Earth. So if center is said to be moving with A, that is what I have taken and marked ACM at certain places. We can mark it as A in which direction I cap. Please do check. Got it?
Yes, sir. Yeah. Yes, sir. Yes, sir.
Which ends with A minus alpha R in which direction? I cap. This is what it is culminating to. Correct? Yeah. This is what it culminates
Yes,
to.
sir.
Please do
Yes,
cross.
sir.
This is what it culminates to. A minus alpha R in direction I cap. If A is greater than alpha R, then acceleration of point P is forward directed. Correct?
Yes,
Yes,
sir.
Yes.
sir.
If it is less, it is directed backwards. If A is equal to alpha R, there is no acceleration to point P. Correct?
Yes,
Yes,
sir.
sir.
Cannot ascribe any acceleration to point P if A is equal to alpha R. Otherwise, we can. Tell me in this case, which one is greater, A or R alpha? Tell me dear. A or R alpha, which one is greater? See for yourself. So R alpha being greater, what you can say
Sir,
about
R alpha is
acceleration to
greater.
point
R
P,
alpha is
backward
greater.
or directed? Will it be directed backward or forward? Point P's acceleration, or will there be no acceleration? Anyone?
It'll be
Will there
backward.
be any acceleration attributed to point P? Yes or no?
Sir, it can be
Attribute
because R
acceleration to point P? Yes or no?
alpha
This
is
point.
greater. So
Yeah, Adesh, you're
Yes,
saying
be
something.
backward. R alpha is greater than A.
Yes, R alpha is greater than A, which is suggestive of acceleration of point P will be backwards, right, Krish?
Yes,
Right,
sir.
Vijan?
Yes, sir.
Acceleration of point P being backward means what to us? If acceleration is backwards, then we know force of friction must try to arrest this relative acceleration, correct?
Yes, sir.
Yes, sir.
Yes,
Now,
sir.
replace it with relative. Can you tell me how can I say this is relative? Yes, we can, as Earth is at rest, correct?
Yes,
Yes,
sir.
sir.
Yeah. Yeah.
So this is
Yes,
also towards relative acceleration, and friction we know always opposes relative acceleration, correct?
Yeah. Yes,
Yes,
sir.
sir.
yes, sir.
Please be careful. This is an important point which I am to raise. Here, there is no rubbing. Here, there is no rubbing. The two surfaces in contact, they are not rubbing each other. Rather, they are not in motion as well, correct?
Yes,
They
sir.
are not in motion. Point P is not in motion. I have started pulling it. I told you it's being pulled. Read the language of question. It was said it's being pulled, correct? Yeah. It is not that it was in the phase of rolling. And then I'm speaking about whether the rolling being pure or with slipping. What was being told by author? It is being pulled, correct?
Yes,
Right,
sir.
sir.
Yes, sir.
So it is being pulled. It is being pulled in no way is suggesting that point P is slipping. Point P may slip, may not slip. The author can tell you that there is no slipping. He can tell you, and I'm telling you, let's say, that there is no slipping. It will not slip. There is enough friction to arrest slipping. Is it okay?
Sir, but
There is
how is
enough friction
Yes,
to
sir.
arrest slipping. Am I clear? If I am not, please add to it. There's enough friction to arrest slipping. Slipping will not happen. Point P will not slip.
how
Yet
is it so
you did
clear, sir?
calculate acceleration. Yet I did calculate acceleration, didn't I?
Sir, one doubt.
Yes.
So how are you so clear that there'll be no slipping, sir?
It's given. It's given in the question that there is no slipping. It's not mandatory, Krish, that there must be slipping. Suppose I keep mu very high. I keep coefficient of friction very high, right, Krish?
Yes, sir.
The force ground. If it is a force ground, I can say that there is no slipping taking place.
Yes, sir.
It's not necessary that the body is rolling, that slipping is a must. Body can roll without slipping as well, Krish. Correct, yeah?
Sir.
So it is rolling. It will roll. It will roll without slipping. Very much possible. This is the reason why I have highlighted the point at this moment. I'm highlighting the point at this moment because there may be a confusion, and very imperative it is. It can come as confusion that the body or point P is slipping. No, dear. It is not for me to take a call on point P will slip or not. It is for author to say whether the body will slip or not. And if the author is coming up with a statement that the body is not to slip, I am to but adhere to what he is asking for, and in adherence I am to say point P will not slip. Then you will ask me what all you are telling about point P's acceleration. Why were you saying that friction will act in the backward direction, forward direction? And what about acceleration if the bodies are not slipping? And this point I was to raise, it cannot be shown in this quantum when we are dealing with laws of motion. But now will be amply clear to you that acceleration is the after effect of force, not velocity. Acceleration is the after effect of force, not velocity. Every force is bound to be accompanied with an acceleration. So every force merits an acceleration. The moment you apply force, at that moment will pop up acceleration. For it to get translated, for acceleration to get translated in velocity, it requires investment on time, right? Yeah.
Yes, sir.
Yes,
So
sir.
when you apply force F, friction will act. Friction is sufficient or not to arrest slipping, that the author is to tell me about. An author told you that there is no slipping. Yet we are calculating acceleration, because acceleration in no way means that the bodies are slipping. Am I clear?
Yes, sir.
Acceleration in no way means that the bodies are to move, let alone slipping. Acceleration is not to be read as bodies being in motion, because the moment you apply force, acceleration is to be attributed to that force, but that force to translate in velocity will require investment on time. So acceleration and force, they are synonyms, but not in velocity. Do you remember I asked you particle what you can comment on acceleration? You remember? Throw the chalk piece up. Particle comes to at rest. Chalk piece comes to at rest over here. Correct? Yeah. What you can comment on its acceleration. Then if you are relating acceleration with velocity, you are bound to fall in the pit. Reason?
Yes, sir.
Acceleration is not to be related to velocity. It is rather to be related with force. Correct? Yeah.
Yes.
So even if the body is not in motion, you are to attribute acceleration to body subject to there being a force impressed on it. Correct? Yeah.
Yes, sir.
Yes, sir.
Are we getting it here? I am going impressive on this point because this is of great import in order getting an understanding on what exactly is acceleration and how it relates to velocity. Is it that acceleration relates to velocity or is the other way around? So you know now that acceleration relates to force and the after effect of acceleration with investment of in time will result in velocity. Right here, the after effect of acceleration with investment on time will result in velocity, correct?
Yes, sir.
Yes, sir.
Yes, sir.
Yeah. When I say force is applied, and when I ask you, let us forego friction for a moment and calculate acceleration. You calculated acceleration. Now you got to see that R alpha is greater than ACM. Thereby, you are of the opinion, I am of the opinion that relative acceleration is in the backward direction. Correct? Yeah.
Yes, sir.
Yes.
And accordingly, we will say friction will act in the forward direction. Correct? Yeah.
Yes, sir.
Yes, sir.
Okay. Now this friction will be Fs or Fk. That author is to decide. And author told you that there is no slipping, correct?
Yes,
Yes,
sir.
sir.
So what will this be? What will this be? Come on, tell me. Author told you that there is no slipping. What will it be?
FK.
Okay.
Fk or Fs? Author told you that there is no slipping, dear. What will it be?
Okay. No.
Fk or Fs?
Yeah.
Fs. S is static, Nadia. Author told you that there is no slipping. So what force of friction is that to be? Fk or Fs? Certainly Fs.
Yes, sir.
Because there is no slipping. So Fs. So this methodology is to make you understand in which direction force of friction will act. Yes, that force of friction is Fs or Fk. That author is to tell you, but this is the only methodology. This is the only methodology by which you can be rock solid on direction of friction. Is it okay? You can say with
Yes.
solidarity that this will be direction of friction without any flinch, no shred of doubt. This is the fool's proof methodology to let you know on direction of friction. Am I clear with this?
Yes, yes, sir.
Yes, sir.
All of you sure?
Yes.
Yes, sir.
Okay, I'm changing this solid sphere or sphere by a ring. Tell me direction of friction. I am changing this solid sphere or sphere as we call by hoop. Either you say hoop or you say ring. Okay, I'll let you know what is moment of inertia. Moment of inertia of a ring is mr square. Idea?
Yes, sir.
Please tell me. Say me something on direction of friction. Say me something on direction of friction. Say me something on direction of friction. You have to replicate this process, and you know now how.
Yes, sir.
The relative acceleration is 0.
Okay, very good, Krish. Relative acceleration 0. How do we get that? This equation will remain unscathed. Give me a thumbs up,
Yes, sir.
all of you. This equation,
No.
center of mass 1, will remain undeterred. No change in that, correct?
Yes, sir.
Okay, so this being unblemished, what about this one?
So that
So
will become
F into R will remain
Fr
as
is equal to mr square
will be
alpha.
replaced. 2 by 5 mr square will be replaced by mr square, right? Yeah.
yes, sir.
Yes, sir.
Okay, tell me then, Adesh, what is R alpha from there? R
Yes.
alpha. Tell me quickly.
So R is equal to mr square alpha. So R alpha is equal to F by M.
Okay, which is what is ACM, correct?
Yes, sir.
ACM is as well Vedant. ACM is also F by M, right, Vedant? ACM2 is F by M. Thereby, what we come to? We come to a conclusion. And what is that, Vedant? R alpha is equal to ACM, right? Yeah.
Yes, sir.
Is what we are getting is R alpha is equal to ACM. Thereby,
ACM.
relative acceleration, as did say Krish, is 0. Relative acceleration, as did say Krish, is 0, right? If relative acceleration is
sir.
0, then why on earth friction will act? Because friction acts only when there is a tendency. And tendency we get from relative acceleration, right? Yeah.
Yes, sir.
Yes, sir.
Relative acceleration is 0, friction will cease to act. And remember this is a very patent question, an overplayed question, where what is the direction of force of friction when you are applying force horizontally? Of course, on a hoop, there will be no friction acting at point of contact. Find ya?
Yes, sir.
Yes, sir.
Okay, so we know now, and also we can with our faculties, derive a theoretical inference. With our faculties, we can derive a theoretical inference. By that, what I mean? Now see for yourself. What is moment of inertia of sphere? 2 by 5 mr square, correct?
Yes,
Yes,
sir.
sir.
What is moment of inertia of ring? Mr square, correct?
Yes, sir.
Yes, sir.
Yes, sir.
If you apply force at a distance, I naught, I want I naught by for a hoop, I naught by whatever is there. I want to apply force. So where should I apply force to get zero friction at point of contact? That is what I'm trying to draw here. And that will be the inference which we can patent. That where shall I apply force so that there is no friction seen acting at point of contact. And that will depend on configuration of body taken. That will depend on configuration of body taken. That is what I am trying to highlight over here. Is it okay?
Yes,
Yes,
sir.
sir.
Yes, sir.
So if you divide I naught by MR, whatever you get, in the case of ring I get R, in the case of sphere what I get here, what I get here, 2 by 5
5 mr square.
correct?
Emma.
Correct? See for yourself.
Yes, sir.
For yourself. So
Yes,
when
sir.
I divide I naught by MR, whatever I get, if I apply force parallel to horizontal at these points means measurement done from center of mass. For ring where? Here. For solid sphere where? For solid sphere where? For solid sphere here. Here, are you getting it? Can you see that yellow mark?
Yes, sir.
Yes, sir.
And what will this be then? 2 by 5R, correct? Yeah.
Yeah, yes, sir.
Yes, sir.
So if you apply for ring here, because you got R, and for solid sphere here, why? You got 2R by 5. Then there will be no friction seen acting at point of contact. Then there will be no friction seen acting at point of contact. Yes, the caveat. Don't you please lose on caveat. And the caveat being force should be parallel to horizontal ground. Correct, yeah?
Yes, sir.
Yes, sir.
Okay, can you tell me if it is a shell? If it is a shell, for shell, it is 2 by 3 mr square, I naught. I naught is 2 by 3 mr square. So where shall I hit the shell with a force parallel to horizontal ground to get zero friction at point of contact?
So 2 by 3 R.
Sir, 2 by 3 are.
I want Adesh to answer. Chris, just hold yourself. Adesh, please do answer. Get me an answer. I naught for shell 2 by 3 mr square. And you are to hit a shell by Q. So where you should hit it, keeping force direction parallel to horizontal. Where should you hit to get no friction at point of contact? Yes, Adesh.
Sir, at 2 by 3 r.
Very good. At 2 by 3R. Can we mark it somewhere here?
Yes, sir.
Yes, sir.
So now you know where should it be hit. S.C. Verma asked a question. I'm asking you all the same. A billiard player hits a billiard ball by a cue. A billiard player hits a billiard ball by a cue. Where should he hit the billiard ball, keeping cue parallel to ground or board? Where should he hit so as to get no reaction at point of contact. So as to get no reaction at point of contact. Clear, dear?
Yes, sir.
Yes, sir.
What will you say?
2 by 5.
So 2 by 5 are.
Fair.
So 2 by 5 are. So 2 by 5 are.
Yes, 2r by 5. Correct, dear?
Yes, sir.
Yes, sir.
So
Yes, sir.
friction is the force of reaction, right, Krish?
Yes, sir. Yes, sir.
Friction is the force of reaction. When you're hitting, then reaction is friction. If the force is in the horizontal direction, then the reaction should also be in horizontal direction, right, Krish?
Yes, sir.
So friction is the reaction. And when will reaction be zero? That you know, right?
Yeah. Yes, sir.
What will be the answer to question given? 2r by 5. Am I clear?
Yes, sir.
Yes, sir.
Okay, very good. So now I think I can secure my position on you all being well equipped with direction of friction, correct?
Yes, sir.
Okay, can I take that for granted, Adesh? I didn't get an affirmation from you.
Yes, sir. Yes, sir.
Okay, very good. Now write down. A rod of mass m length L. A rod of mass m length L is free to rotate, is free to rotate about point P. A rod of mass m length L is free to rotate about point P. An impulsive force in the bracket right, large force acting at a small time, large force acting for a small time, large force acting for a small time, bracket close. An impulsive force F is applied, as shown in the figure. An impulsive force F is applied as shown in the figure. Find equation for reaction at the point of pivot. Find equation for reaction at the point of pivot. This is the point of pivot P, about which the rod can rotate. Hence derive equation for instantaneous center of rotation, subsequently instantaneous center of rotation, subsequently point at which instantaneous center of rotation, subsequently point at which reaction is zero. Point at which reaction is zero. Now, the one which we'll be discussing today on board. You will not get anywhere. Let me add to it. Nowhere you will be able to find it. And the end result is to get you a formula. And that formula is very handy in locating instantaneous center of rotation. And the same formula I'll use to find reactive force. As called the case of billiard ball, if you can recollect, by using our knowledge on force of friction and reaction. Correct, dear?
Yes, sir.
Yes, sir.
Yes, sir.
The same question after deriving a theory. So this theory which you will get only over here is very handy in solving difficult questions. So please pay heed to the way that we are getting towards the end of it, and ask me wherever is a doubt arising, please stop and ask me then and there. Clear, dear?
Yes,
Yes,
sir.
sir.
Yes, sir.
A few disclaimer, you don't know what is impulse. I'm letting you know that impulse is nothing but product of force and time of application of force. Is it okay?
Yes, sir.
Product
Yes,
of
sir.
force and time of application of force. Correct, yeah?
Yes, sir.
Yes, sir.
Also impulse, if you are to club it with Newton's law, if you are to club it with Newton's law, then you can say impulse is nothing but change in momentum. Clear, dear?
Yes, sir.
Impulse is
Yes,
nothing
sir.
but change in linear momentum. Is it okay? Check, dear.
Yeah, yes, sir.
Yes, sir.
So that is impulse to us. Anyway, I have written over here, this is the impulse. A very large force is acting for a relatively shorter period of time, delta t. And the moment you will hit, the moment the rod was free in its skin, what you did, you made an impact. Correct, dear?
Yes,
Yes,
sir.
sir.
Yes,
An
sir.
impact. And as you make an impact, you will feel there being some change at the nib of your index finger and thumb. Can you say that? See for
Yes,
yourself.
Yes.
Hold a pen and try to hit it here. What will you find? You'll find there being some uneasiness at the tip of your index finger and thumb. Agreed?
yes, sir.
Yes,
Yes,
sir.
sir.
Okay. Why is that to be seen? Why am I experiencing whatever am I? Am I experiencing that or not? First tell me. Yes? All of you guys
Yes, sir.
are.
Yes, sir.
And then comes that why am I into experiencing such a jerk? Why is that I'm experiencing a jerk or an uneasiness here? Why is it getting numb? If I keep on hitting, this will get numb. Why is it so? It is so because I am trying to resist reaction. I am getting a reaction. The moment I hit it over here, it is to react. Everywhere, everywhere, you will see there being a reaction. Now let me change the orientation and make you understand. When you hit
Your
this
screen
point
is
here,
freezing.
when you hit this point, is it visible?
Yes, sir.
Yes, sir.
Then this point tries to move forward, correct?
Yes,
Then
sir.
this
Yes, sir.
point, what will try to move, it will try to move forward, right? Yeah, it will try to move forward, correct?
Yes,
Yes.
sir.
Yes, sir.
But as this point tries to move forward, what will the holder try to do?
I'll try to
Holder
resist it.
will try
Sir,
to stop
resist
it,
it.
correct?
Yes, sir.
Because this point has got acceleration forward and holder has got no acceleration, so it will try to stop it. Stop it by applying force in which direction? Backward direction, correct?
Yes,
Yes, sir.
sir.
Yes.
So if holder will apply a force on this chalk piece in the backward direction, will the chalk piece let go of it? Will it take it lying down? No, the chalk piece is not to take it lying down, correct, dear? What will the
Yes, sir.
chalk piece do? It will apply a counter force, yes or no?
Yes, sir.
Yes, sir.
Yes,
So
sir.
chalk piece will apply in turn a force on holder. In which direction? Forward direction,
Forward.
agree?
Yes,
Yes,
sir.
sir.
Yes, sir.
So if the pattern which I'm suggestive of is to continue, then everywhere you will get the force that you have applied distributed.
Yeah, yes, sir.
Think about it. Will not be seen everywhere a reaction. Take any point. Take any point. Now take my hand. Take the finger. This board, this one now. Forget about chalk piece. This one, the holder. The chalk piece holder was trying to move forward. Why? Because force was applied by chalk piece in the forward direction. Say yes or no?
Yes,
Yes,
sir.
sir.
And what is my finger to do? My thumb is to stop it, correct?
Yes,
Yes,
sir.
sir.
Yes,
So
sir.
my thumb will apply force in which direction? Backward direction, yes or no?
Yeah, yes, sir.
Yes,
Yes,
sir.
On the chalk piece holder, my thumb will apply force. Our fingers are to apply force in which direction? Backward direction, correct? Yeah.
Yes, sir.
Yes, sir.
So what kind of force you are getting? Chalk piece holder is trying to move forward. Fingers are trying to stop it by applying force in the backward direction. What will chalk piece holder do? Oppose this force, correct?
Yes, sir.
Yes, sir.
Yes, sir.
I am applying force on my fingers in which direction?
Forward.
Forward direction. Correct here, got it?
Yes, sir.
Yes,
Got it?
sir. Yes, sir.
So when we hit a particular shot, when I am playing lawn tennis and I am to hit a back shot or a front shot, whichever shot I am to hit, I am to make a rally, then I am holding the handle easy. If I am to hit a particular shot, then the book will indicate where should you hold it firmly, where you should make a grip, where you should fist the handle. That the book will tell you that okay, you are serving, you should hold it here. You are into a back shot, you hold it somewhere. You are into a front shot, hold it somewhere. So do you think that for every shot there is one position, or we keep on changing our position of hand on handle? Do we have different position of hand on handle for
Yes, sir.
a back
Yes,
shot,
sir.
or is it same for back and front? What do you say?
You'll
So
have
we
different.
change the
Sir,
position.
different.
We have different. And can you tell me what will happen if I am not to change position? Any detrimental, anything which is very blasphemous to happen if I don't change my position? Any which can inflict pain on my wrist?
Yes, sir.
Yes,
There
sir.
be-
No.
are you alluding that there will be infliction of pain, or to the extent that I run a risk of breaking my wrist? I run a risk of breaking my wrist if I am not in adherence to the point of fist. Are you suggestive of this?
Yes, sir.
Yes, sir.
Yes. Yes, it is. I took lawn tennis as example, not cricket, because in cricket, to some extent, bat is able to restrain that reactive force. But the racket, lawn tennis racket being very light, so you do run a risk of breaking your wrist if you're not holding it at a particular position, whichever is designated. Is it okay, dear?
So one
Yes,
doubt.
sir.
So does it imply that heavier the racket or something, more the less the risk of breaking your
Yes, because then they have their own inertia, right, Rick? Right,
yes,
Krish?
sir.
And
Yes,
that
sir.
own inertia will ask for some abate on force. Force will get abated. Why? Because you have to move a larger mass body. Clear, yeah?
Yes, sir. Yes, sir.
But if on contrary you are to a much lighter racket, of course, in order to stop it, if you are leaving it, no problem. Leave it. Let the racket fly. But if you are holding it, then you will have to bear the brunt. Racket will be no support to you. Correct? Yeah.
Yes, sir.
Yes, sir.
Yes, sir.
So in cricket, to some extent, it will be able to, but in lawn tennis, we are certainly running very thin ice on securing our wrist. Then the question, what is that position which we hold the racket or handle of the racket at? Which position shall I find? Position I'll adhere to. But I want to go deep in it. I want to go much deeper and ask myself, how did that person get to know about position? Then the person will say, as per his experience, fine. but there must be something physical, something mathematical to support your experiment. Correct, yeah?
Yes, sir.
Yes, sir.
You cannot just say intangibly, no, I have decided and I'll be on my whims and fancy. This is the point that you need to hold. What if the length of racket or what if the length of handle is changed? Then the position will also change. So I would like to know what mathematics, what is that term which will decide where should I hold the tennis racket? What decides? Which which element decide over here the point of hold? Not only tennis racket, day to day. Suppose you want to hammer a nail in wall. Find it.
Yes, sir.
If you want to hammer a nail in wall, then you hold the stack of hammer at a particular position. Agree?
Yes, sir.
Yes, sir.
You cannot willingly hold it at any position. You may start willingly holding at any position, but with time, if you are to make hit many a time, then with time, what will you do? You will change position to a secured one. Correct? Yeah?
Yes, sir.
Yes.
Can you tell me what I mean by secured one? What I mean by secured one?
So a position where we can get a good firm grip on the handle or
Firm grip. Firm grip can be, if at all firm grip I am to get, I'll go by that. Firm grip. But firm grip can be marred by jerk. Correct? Yeah.
Yes, sir.
Firm grip can be marred by jerk. If I'm getting jerk every now and then, I make a hit and I get a jerk. So what will happen to my firm grip? My firm grip is to get shaken. Correct? Yeah. Say me yes or no?
Yes.
yes, sir.
So by firm grip, what I am to read of your firm grip word here is a grip which is getting me zero reaction.
Yes, sir.
Yes, sir.
A grip which is, or a position of grip which is getting me zero reaction. There should be no reaction. You should not get jerk every other time you make a hit. You should not get jerk. And the same goes for lawn tennis. When you are into a back shot, when you are into a front shot, you are changing the position of handle. You know why? Because you want the grip to be firm. You want your fist to be in fist mode, firmly clenched. Firmly, if the fist is to be firmly, the finger and the fist is to be firmly clenched, then that clinch should be secured by absolute zero. We can never get absolute zero yet, I say. Absolute zero jerk. And absolute zero jerk means what, dear? Absolute zero jerk means no reaction. Absolute zero jerk means wherever you are holding it, at that point, you should not get a reactive force, a reaction. A reaction to what? A reaction to event. What is event over
Yes,
here?
spin is
You hitting
frozen.
a shot. The idea?
Yes, sir.
Yes,
What is
sir.
event? In case of hammering of nail in the wall, you making a strike. Correct, yeah?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, so every strike, every shot that you play should not in any way translate to jerk. If it does, we are running a risk. Right, dear?
Yes,
Yes,
sir.
sir.
With this, what I am to highlight is whenever there is an impact, whenever there is an impulsive force which acts on a body, then there inside of a body will lie a point. Inside of a body will lie a point, 1 point, single point, where reaction is ought to be zero. Where reaction is ought to be zero. That point can be outside as well. But at the beginning, I'm not to confuse you. So I am telling you that there must lie a point where reaction, when calculated, should get us a null, a naught. And there is certainly for everybody, there is a point where reaction is a naught, a zero to us. And if reaction is a naught, let me ask you, if reaction is a naught, on technical term, what will you say? You will say force acting is zero. Remember
Yes.
friction force is the reaction? Yes or no?
Yes, sir.
Yes,
Remember
sir.
in the previous case, billiard ball, friction force was the reactive force, correct? Yeah.
Yes, sir.
Yes, sir.
So reaction being zero on technical front, it is to be then said force acting being zero, correct?
Yes, sir.
Yes, sir.
Force acting zero means acceleration zero, correct?
Yes,
Yes, sir.
Acceleration zero means velocity constant, correct?
Yes,
Yes,
sir.
sir.
And if the point was not moving initially before the event, then velocity is constant and that constant is zero as well.
Yes,
Yes,
sir.
sir.
I said velocity constant, I didn't say zero. I deliberately stopped
Yes,
short
sir.
calling it zero. It can be any constant. Then I added to it that initially the body was at rest, correct? Yeah.
Yes,
Yes,
sir.
sir.
So that constant will be zero to us, correct?
Yes, sir.
Yes, sir.
Okay. To see the hierarchy, please. Please see the chronology. Please be very mindful of chronology followed. The algorithm that I'm following. First, reaction zero, then acceleration zero, then velocity constant, then initial state. Was that point at rest? Yes, it was before of event. So it will remain rest forever. Correct, yeah? After of event also it will remain at rest. Forever I won't say, but if before of event it was at rest, then after of event also it will be at rest. Can we say that?
Yes,
Yes.
sir.
And if any point is at rest, if any point is at rest, then that point qualifies to be called instantaneous center of rotation.
Yeah, yes, sir.
Yes,
If
sir.
any point is at rest, then that point very willily so we can put an epithet, and that will be what to us? Very cogently. We can very cogently say that it is nothing but instantaneous center of rotation. Agreed?
Yes,
Yes,
sir.
So from here, we get an idea on ICR. Whatever is on board, which I will be for you articulating, you will get an idea on instantaneous center of rotation in a snap without doing a thing. And that is what we are to culminate this class with. Tell me class, F delta T here, correct?
Yes, sir.
yes, sir.
Now F delta T, the moment you make an impact, there will be a reaction force at hinge.
Yes, sir.
There will be a force of reaction at hinge or not? Think about it here. Force of reaction at hinge, will it be there or not?
Sir.
Yes.
And I'm not sure of the direction. I don't know in which direction it will be, firstly. Secondly, even if I'm sure of direction, direction will keep on changing with orientation of rod, correct?
Yes, sir. Yeah.
Yes, sir.
Reaction force keep on changing with orientation of rod to secure myself on change. To secure myself off this change, what I do, I break it in two components. I'm secured, correct, yeah?
Yes, sir.
Break
Yes.
it in two components, Rx and Ry. Find here, what are they? They are impulsive reaction along X and Y direction. Find here.
Yes, sir.
Z we have
Yes.
not taken because Z doesn't bode well with us. Why is Z not to augur well? The plane of rotation being XY. Correct, yeah?
Yes, sir.
Yes, sir.
So verily, we have decided on it verily that force will produce impulse to the right and reaction will be to the left, and that reaction being marked Rx. Can I write F minus Rx delta T as impulse in X direction?
Yes, sir.
Check it
So
here.
one
Check it.
second. Yes, sir.
Yeah.
1 second.
Yes, yeah.
Yes, sir, we can.
This we can write as impulse in x direction. Impulse a vector quantity, as you can see for yourself. So impulse in x direction, correct here. And
Yes,
what is
sir.
impulse x direction to be equated to change in momentum in x direction, correct?
Yes, sir.
Yes, sir.
Okay, you all are barely agreeing to it, correct? Yeah.
Yes,
Are you
sir.
all barely agreeing to it? Is
Yes,
it
sir.
viable or not?
Yes, sir.
Yes, sir.
Agreed.
Momentum along x direction, impulse along x direction, they are to be equated here. So this is impulse along x direction, which should be equated to momentum along x direction. Now momentum along x direction means what? Momentum of a body, of a point, if it is, we write m into v, correct?
Yes, sir.
Yes, sir.
But for a body, what we write? We write mass of body into velocity of center of mass. Is it okay?
Yes, sir.
Is it okay? What we then treat point to be at is center of mass of body. Clear here?
Yes, sir.
Yes, sir.
Okay, so m into VCM minus 0. This is the momentum change along x direction. Impulse. Good. Where from you got this formula? Can you recollect from here? Correct?
Yes, sir.
Yes, sir.
Yes, sir.
Do you have a similar formula in rotation? Do we have a similar formula in rotation? Will you labor me out on this one?
Yeah. Yeah. Yes, sir.
Yes, sir.
Do you have the reminiscence intact or not?
Yes, sir.
Yes, sir.
So from here, what we can say about dl? dl is equal to tau into dt, right? Yeah.
Yes, sir.
Yes,
Yes,
sir.
sir.
So tau into dt is similar to f into dt, correct? Yeah.
Yes, sir.
Yes, sir.
And the delta p there can be marked as delta L here. Check it here. Check it. Fine.
Yes,
So,
sir.
Yes, sir.
yes, sir.
Here or not? Just check it here.
Yes, sir. Yes, sir.
Yes,
This
sir.
is
Yes,
change
sir.
in linear momentum. This will be change in angular momentum. Fine, yeah.
Yes,
Yes,
sir.
sir.
So if I am now to shift my focus on the rotational aspect, and I am calculating rotation about point of pivot, is it okay?
Yes, sir.
Yes, sir.
Then reaction cannot produce any torque because reaction Rx, Ry, they are passing through it, correct? Yeah.
Yes, sir.
Which is the only force that can be deemed to produce impulse F
Yes,
into
sir.
delta T, correct?
Yes,
Yes,
sir.
sir.
And you
Yes.
know that torque is nothing but force multiplied with perpendicular distance, correct?
Yes,
Yes,
sir.
Yes,
sir.
sir.
I am marking this and that is for a purpose. I'll let you know. A and B, I am marking them as A and B. Of course, over here, A is equal to B is equal to L by 2, where L is the length. Is it okay?
Yes, sir.
Yes, sir.
Okay, but I'm marking it in terms of A and B. I wish you write it in terms of A and B only. Okay?
Yes,
Yes,
sir.
sir.
Being very specific, you are not to get it this way. A and B are ought to be different in the questions which you are to place to. Now, F is F into perpendicular distance. What is perpendicular distance? A plus B. Can you say that?
Yes,
Yes,
sir.
Many a question,
Yes.
mind you, will place to many a question on this concept. F A plus B, perpendicular distance, and multiplied with delta T right here.
Yes, sir.
Yes, sir.
Impulsive torque delta T is to it. Of course,
Yes, sir.
accompanying India.
Yes, sir.
Yes, sir.
Delta T is accompanying it. Now to the right of equality. The right of equality is angular momentum. Angular momentum about which point? P.
E.
Angular momentum about which point here? P. So what
Yes,
we
sir.
can write? IP into omega minus 0. Check it here. IP into omega. I write it over here. Is it visible?
So here omega is the angular velocity with which the rod is rotating.
Yes, with the angular speed or velocity, you can say, fine. With which the rod is rotating. Is it okay? Is it visible? I've
Yes,
highlighted
sir.
with yellow color chalk piece. Find here.
Yes, sir.
So what do we get to see from here? This is the first one is impulse. Impulse translational. The second one is also impulse. Impulse rotational. Clear? Yeah?
Yes,
Yes,
sir.
sir.
Yes, sir.
First one we are getting from Newton's second law of motion. Second one we are getting from dl by dt is equal to tau external. Am I clear to all of you?
Yes, sir.
Yes, sir.
Okay. And then what we can say? We can say that omega means the speed or velocity with which the rod is rotating, and omega can be related to VCM. How? VCM is equal to A into omega. V is equal to R omega. We
Oh,
know
yes,
V
sir.
is equal to R omega, right? Yeah.
Yes, sir.
Yes, sir.
And what is R here? R is the radius, isn't it? Velocity, circular motion again apart, velocity, just write it down, dear Vedant and Adesh. If velocity is v and omega is the angular speed, then v is equal to L into omega. We'll prove it. Is it okay?
Yes,
The
sir.
velocity is v and
Linear speed. V is linear speed and omega is angular speed. R is the radius.
okay, sir.
Okay. So here V means VCM. Correct, Vedant? Sorry, correct, Adesh?
Yes, sir.
V is VCM. Perpendicular distance how much to us? A to us, correct?
Yes, sir.
And angular speed with which the rod is rotating is omega, correct?
Yes, sir.
Yes, sir.
So VCM is equal to A omega. Clear, Vedant?
Yes, sir.
Okay. Now there are three equations with you. 1, 2, and 3. These equations are now to be mathematically manipulated. So I'm making some space for myself here. These equations now are to be manipulated to get what I am eyeing. And what I am eyeing, I'll curry some favor from you. I'll try to curry some favor from you. Okay, Krish, I start with you. Krish,
Yes, sir.
can you tell me a substitution for VCM?
The VCM can be from A omega.
Okay, so I'll write that down. VCM is written as M as it is, A into omega, right, Krish?
Yes, sir.
Okay. And then F A plus B into delta T is equal to. Now I about which point, class? I about point P. I about point P.
Yeah.
And write down. Write down. Which again I'll prove. Write down somewhere that I'm saying that I'll prove and ask me whenever you have a stray class. It can happen today itself. Okay? What is it? Moment of inertia about any point. In bracket axis. Moment of inertia about any axis. Which is parallel to axis. Which is parallel to axis. Passing through center of mass of given body. Which is parallel to axis. Passing through center of mass of given body. Can be related as now look over here, class. There are two axes. There are two axes which I am taking. One is passing through P and the other center of mass. Is it okay?
Yes, sir.
Yes, sir.
One is passing through P perpendicular to plane of board. The other is passing through center of mass perpendicular to plane of board. Clear, dear?
Yes,
Yes,
sir.
sir.
Yes, sir.
They are parallel to each other, right, dear?
Yes, sir.
And what is separation between them? A, correct?
Yes, sir.
Yes, sir.
Then IP can be proved. We can prove that IP will be nothing but I naught plus MA square. We can prove this. This is called parallel axis theorem. For now, take it on face value. IP is moment of inertia about an axis passing through P. And that axis happens to be parallel to an axis passing through center of mass. That axis happens to be parallel to an axis passing through center of mass. And accordingly, we get IP is equal to I naught plus MA square. This we will prove with a heading, parallel axis theorem. There is another theorem which is called perpendicular axis theorem. I'll come to them. Maybe after of this I'll come to them. Is it okay? So for now on face
Yes, sir.
value, can I then write IP as I naught plus MA square? Do you approve of it?
Yes, sir.
Yes, sir.
Okay. So IP here, IP being replaced by this P, IP being replaced by I naught plus MA square and omega as it is. Fine, Adesh?
Yes, sir.
Okay, now right. Now right. Writing I naught as MK square, where K is radius of gyration. This you know, correct? Yeah.
Yes, sir.
Yes, sir.
Writing I naught as MK square, where K is radius of gyration.
Yes, sir.
And dividing 1 by 2. This is 1, this is 2. AB, make it dividing A by B. Dividing A by B. Equating Rx to 0, we get. Dividing A by B. Equating Rx to 0, we get. Tell me what are you getting? Dividing A by B. Equating Rx to 0, we get. Tell me what you get here.
So 1 second.
All of you, please do exhibit. Exhibit, all of you. You are dividing capital A equation marked over here by capital B, and you are equating with Rx being assumed 0, correct?
Yes, sir.
Yes, sir.
See what you get at the end of calculation. F will get cancelled, delta T will get cancelled, you will be getting a very amicable equation eventually.
So A plus B is equal to K square plus A square.
A plus B is equal to A square plus A square. Is it? Check once. Check your calculation once. Rx
Sir, K,
0.
sir, K square is equal to 1 by A plus B.
1 by A plus B.
I don't know. I'm just waiting for the correct answer if I can get
One
from any
second.
one of you. Rx you are to equate to 0, divide them and get a relation between K, A and B. K, A and B. K, A and B.
Yes,
By
one.
Any change? Any reevaluation?
Sir, I'm getting thing A is equal to K square A plus K square B plus A square plus AB.
Okay.
K square.
What are you getting, Adesh?
So I'm getting K square is equal to A minus A square plus B. Just as K, sorry, wait, no. Yeah.
Sir, I'm getting weird, very weird one, sir.
What is it?
The k square is equal to a minus a
Oh
square
no, wait,
minus
wait.
ab by a plus
I
b.
think I got.
How are you getting these equations? Yeah, I have just asked you to divide A by B. When you divide
So
A
wait,
by
I think I got it. So is
B,
k square equal to a plus b ab? K square is equal to ab.
are you sticking your neck out on that? Sure.
Sir, I got k square is equal to ab.
Yeah, that is the right equation. K square is equal to AB. K square is equal to AB. This is a very important relation, not to get anywhere. So please highlight it in full forward. K square is equal to AB. And don't lose sight on, you got it when you have assumed Rx to be 0, correct?
Yes, sir.
Yes, sir.
So let me place this dangling rod on a smooth horizontal table. Clear?
Yes, sir.
Yes, sir.
Place this dangling rod on smooth horizontal table. Then you are absolving yourself of Ry because Ry will be 0. Correct, yeah?
Yes, sir.
Yes, sir.
Yes, sir.
Let me do Ry as it is on horizontal smooth table. Correct, yeah?
Yes, sir.
Yes, sir.
Yes, sir.
When you hit a rod kept on horizontal smooth table, look, I'm making the impact. I make a hit. Is it okay?
Yes,
Visible?
sir.
Yes,
I
sir.
make a
Yes,
hit
sir.
here. If I make a hit over here, then everywhere I will get reaction, correct?
Yes,
Yes,
sir.
sir.
I'm trying to find that point where reaction will be 0, correct?
Yes,
Yeah,
sir.
yes, sir.
So reaction will be in which direction? Only in x direction, and because Ry is 0, it is no more dangling, correct? Yeah.
Yes,
Yes,
sir.
sir.
Yes, sir.
We are finding for point which is to read Rx 0, correct?
Yes,
Yes,
sir.
sir.
And by reverse logic, what we can say, Rx will be 0 if k square is equal to AB, correct?
Yes, sir.
Rx will be 0 if k square is equal to AB, correct?
Yes, sir.
Yes.
Yes, sir.
And if Rx is 0 and you follow the algorithm, then you can say that that point will qualify being called instantaneous center of rotation, right?
Yes, sir.
Yes.
Yes, sir.
Rx is 0 and we follow the hierarchy, the algorithm which we have entailed. Then what I have entailed an algorithm. I presume you have taken note of it, correct?
Yes, sir.
Yes, sir.
So if I am to, then what will happen? Then will that algorithm, what we can come to, we can say that yes, this point is qualified to be given an epithet instantaneous center of rotation. Clear?
So one doubt.
Yes.
The
It is.
A and B in general, what will it be?
Yeah, what are A and B? Very genuine doubt, pertinent doubt. What are A and B? First of all, both are measured from center of mass. Okay?
Yes,
See for
sir.
yourself. Mass, B also from center of mass. So the measurement begins at center of mass. Is it okay? That is the benchmark for us. From there you graduate. From there you calibrate. Is it okay? So calibration point
Yes.
is center of mass. Am I clear?
Yes, sir.
Yes, sir.
And what are they? What are these point to you? First one is the point of impact. Second one is the instantaneous center of rotation.
Yes, sir.
Okay, first one is the point of impact. See for yourself. B is the distance of point of impact from center of mass. Correct, yeah?
Yes.
B is the distance
Yes,
of
sir.
point of impact from center of mass. Yes or no?
Yes,
Yes,
sir.
sir.
Yes,
And
sir.
A is the distance of instantaneous center of rotation from center of mass. Correct?
Yes, sir.
A is
Yes,
the
sir.
distance
Yes,
of
sir.
instantaneous center of rotation from center of mass. Now you may be baffled that why I'm calling this point instantaneous center of rotation. Because we have got k square equal to AB when Rx is equal to 0. Correct, yeah?
Yes, sir.
Yes, sir.
If
Yes, sir.
Rx is 0 and you have absorbed yourself of Ry, then will it not act instantaneous center of rotation? Agreed or not?
Yes,
Yes,
sir.
sir.
Yes, sir.
So one is any of the two can be taken as per you, whatever you are to get suited with. I am taking any of the two. One will be, of course, first point, very important point. They are both to be measured from center of mass. Calibration is to be done from center of mass. All the graduation from center of mass. Now one is the point of impact from center of mass. The other is ICR from center of mass. Clear?
Yes, sir.
Yes, sir.
Clear, Krish?
Yes, sir. And one more doubt, sir. Is it
Yes.
compulsory that both of them are to be on the same line, along the same line?
It is compulsory. It is compulsory that both are to be on same line, but not to both being same side of center of mass.
Okay. Yes, sir.
Line will be same. Side must be different. If they are
Yes,
at
sir.
same side, then you will never get a reaction which is not moving. You will never get a reaction point which is not moving. Okay, you will always get it to be in moving mode. Suppose, can ever be any point at rest this side of center of mass? No. On the
Yes.
same side as impact? No. So which side it should fall? It should fall to the other side of center of mass. Clear, dear?
Yes, sir.
Yes, sir.
Okay. Let me now get to the question which I did ask you. Let me ask on how to find ICR and taking the same billiard question. Taking the same question, billiard question. This is the ball. This is the point where it is touching ground. This is where reaction is to be seen. And I want my reaction to read a naught. I want my reaction to read a 0 or naught. Is it okay? So
Yes,
where
sir.
shall I hit?
Yes, sir.
Where shall I hit? For there being no friction here. And this time I want you to follow k square is equal to AB. Clear, dear?
Yes, sir.
Yes, sir.
Yes, sir.
First things first, what will I do? I'll locate at the center of mass.
Yes, sir.
Okay.
Yeah.
And then I'll look for the point of impact. This is the line of impact, isn't it, dear? Line
Yes,
of
sir.
Yes,
impact,
sir.
correct, dear?
Yes,
Yes,
sir.
sir.
Okay, line of impact. The three-dimensional body, so I'll have to take line. Are you getting it?
Yes, sir. Yes,
Yes,
sir.
sir.
So this is the line of impact, this is the line of impact, and this is the distance x, which I have to find. And
Yes,
then,
sir.
if this point reaction is 0, what you qualify calling this point?
The ICR.
ICR, very good. So this is ICR, and what is distance of ICR from center of mass? Capital R, R is the radius.
Yes, sir.
Yes, sir.
Then we use k square is equal to AB, correct, dear?
Yeah.
K
Yes.
square for a sphere is known to you. 2 by 5 R square. We have read about it, correct, dear?
Yes, sir. Yes, sir.
Yes, sir.
Yes,
Okay,
sir.
what is A? I am keeping A as the unknown X, correct? And what is B? B is R, correct, dear? Check it out.
Yes, sir.
What do we get X as? 2R by 5, right, dear?
Yes,
Yes.
sir.
Yes, sir.
If you will hit at 2R by 5, we will not get any reaction over here. This is what we found otherwise as well. For no friction to be here, it should be hit at 2R by 5. Correct, dear?
Yes, sir.
Yes, sir.
It was found by different methodology. Here we are using the formula k square is equal to AB. Fine. Fine with all of you?
Yes,
Yes, sir.
sir.
Yes, sir.
Okay, just to consolidate your position, let me ask for the rod which is kept on smooth horizontal table. This is smooth horizontal table. There's a rod placed and you make a hit at the corner, at the edge of the rod, at the end of the rod. You make a hit at the end of the rod. Length of rod is L. And you make a hit parallel to plane on which it is kept. Is it okay?
Yes, sir.
Yes, sir.
Yes, sir.
Mass is M, length L, you make a hit. Tell me where will lie ICR? Please reserve your answer. I'll be going individual. Tell me where will lie ICR? That one point which just after impact will be at rest. Mind you, that point is not to remain at rest ad nauseum. Correct, yeah? It
Yes,
is
sir.
not that
Yes.
point will remain over there only and the rod will move. That is not the case. That point will also move, but for that instant there will be no reaction, correct?
Yes, sir.
Tell me, calculate and get known where will lie instantaneous center of rotation. Think about. This is a rod of mass and length L. Rod of mass and length L. If done, please register by saying you are done.
So is it equal to R, the radius? The edge?
If you answered, yeah. If you are done, then please just register by saying that I'm done. Are you done, Adesh?
Yes, sir.
Okay, Krish.
Yeah, 1 second, sir. I naught for a rod is
Rod, moment of inertia of fine. I'll let you the moment of inertia of rod. Moment of inertia of rod.
So ML
Moment
square
of
by
inertia ml square by 12. Is it okay?
yes,
Oh,
sir.
mr square by
ml
12.
square by 12.
Oh.
Yes.
Okay, I begin now. Yes, Adesh, your answer.
So I got, so once R square by 6L.
R from where you are getting, Adesh? Where is R in this?
Sorry, sir, once. So, so L by 6.
L by 6, right. That is the answer. K square will be replaced by L square by 12. Correct, yeah?
Yes,
Yes.
sir.
K square will be replaced by L square by 12. Right, all of you?
Yes,
Yes,
sir.
sir.
Yes, sir.
And it can be replaced by L by 2.
Yes, sir.
Yes, sir.
Mass by 2. And B we are to find. So B will be L by 6, correct?
Yes, sir.
Yes, sir.
Yes, sir.
See which side? To the side of impact or opposite? You got L by 6, okay, that is quantum. But where will lie exactly the ICR? Will it fall to the side of impact or the opposite?
So it'll be opposite, sir.
So
Be opposite. Of course, it should be opposite and will be opposite, right? So
Yes,
where
sir.
will lie ICR? ICR will lie over here. At what distance from center of mass? L by
L by 6.
Yes, sir.
Yes, sir.
Yeah, okay. So I'm keeping to this today. Revise the portion, all of you. Fine.
Yes, sir.
So we'll be having class in the evening.
These are all problems for you, and problems are to keep coming. Yes,
Yes.
you were asking something?
Do
Were
we
you?
have class in the evening also?
Yeah, we'll be keeping one in the evening because we are to get done with the electric portion as well. What is the engagement in the evening, Krish?
So nothing, sir. I'm free throughout the week.
Okay, I'll just see that it can be positioned today in the evening and let you know about it before.
Sir, 11th or 12th? I'm just asking, sir.
12th, it'll be 12th. 12th, 11th, what? Adesh, are you free? Evening? In the
So
evening?
my mother has her tuition.
From when to when?
So from 5 o'clock onwards.
5 o'clock. Before or 5 you're free, right?
Yes, sir.
So let me check and accordingly we'll intimate, right, Krish?
Yes, sir. Sure, sir. So just ask, sir.
Okay, fine. Okay.